Thank you everybody, young and old, if you're joining us on this Wednesday evening, the 6th of March 2024. Okay, my name is Coach Nawaz. I will be with you for the next 1 hour, and in this 1 hour that we have today from 8 p.m. to 9 p.m, we're going to go through a topic that should be familiar to those of y'all who are doing O-levels. Okay, we're going to do circle properties. Okay, circle properties. Don't let the warm-up question throw you off. We're going to do properties of circles. Okay, properties of circles. It's a very important topic if you're doing secondary school maths, especially upper secondary. If you're doing O-level maths, this is something that will definitely find its way into your O-level exam paper. Okay, so 𝐒𝐞𝐫𝐡, is this P5? No, I'm sorry, it's not P5. Was it named as PSLE maths? I hope not. This is secondary school maths. Those of you all joining me on TikTok, on Instagram, this is secondary school maths. Okay, but we have a bit of a brain teaser here to start us off. Okay, we have a bit of a brain teaser here. You might be wondering, what is this brain teaser doing here in a secondary school maths topic? Well, obviously it's not related to properties of circles. Just to get you guys warm up lah, just to get you guys warmed up. Okay, before we get started on the lesson proper. Okay, Mrs. Naidu is 31 years old. Her son is 4 years old. How old will Mrs. Naidu be when she is 4 times as old as her son? Okay, yeah, Gracelyn, yes, everybody needs circles. Okay guys, warm-up question. If you're joining us on Instagram, joining us on TikTok, is the answer A, B, C or D? A, B, C or D? Okay, let's see. Those of us on Instagram, okay guys, A, B, C or D? Okay, some people are saying D. 𝐒𝐞𝐫𝐲𝐽 says D. Okay, what do you guys think? How old will she be when she's 4 times as old as her son? 𝐒𝐞𝐫𝐲𝐽 says D. Any other responses? Cyclone Boy says D. Cyclone Boy says D. Seems like a lot of y'all are saying D. Well, at least 2 of y'all are saying D. Okay, the topic is circles. Today the topic is circles, but this is just a warm-up question, just a little bit of a brain teaser. Okay, because obviously when you go into secondary school, you don't want to forget what you've learned in primary school, right? Some of your secondary school students might have younger siblings in primary school. So important that you keep yourself up to date with what's happening in primary school. Primary school, usually this kind of topics will be tested. This is something that we tell all our primary school students. Okay, when you talk about the ages of 2 different people, okay, maybe I write it down here lah. When we discuss the ages of 2 different people, always remember that their age gap, quite lengthy this thing I have to tell you all. Always remember that their age gap remains, okay, this one I put in red constant. I love teaching primary school maths. So much easier than secondary school. I'm just kidding. Okay, so when we discuss the ages of 2 different people, okay, a mother and her son, a father and his son, 2 siblings, grandfather, grandchild, whatever lah, the age gap will always be the same. So Mrs. Naidu is 31 years old, the son is 4 years old, the difference in age is 27 years. Okay, so when we draw our bar model, bear this in mind. Okay, so I take it you all have copied this. if you all are joining me with a notebook in hand, always remember lah, Wednesday night, 8 p.m. to 9 p.m, sit in front of your phone with a notebook, your stationery, your calculator. Alamak, where's my calculator? Okay, I ask you all to bring calculator. I myself don't know where my calculator is. Okay, never mind. Later, maybe while you all are practicing something, I can go find my calculator. Or actually, I got my phone, I can use my phone also lah. Okay, so when we discuss the ages of two different people, always remember that their age gap remains constant. So I'm going to draw a bar model now. Okay, I take this thing away first. Can I zoom in? Very good, very good. I like using this app. Very friendly. Okay, so now we draw a bar model. We draw a bar model, guys. Mrs. Naidu, we put MN. The son, we put S lah. Okay. Then, their question is asking, how old? Okay, let me highlight this. How old will Mrs. Naidu be? Okay, the one who's asking what is the name of the app. The app here that I'm using is Notability. Notability. I don't get any money from them, but trust me, it's a good app to use. I like using it. Notability. Okay, but back to the question. How old will Mrs. Naidu be when she is 4 times as old as her son? So, based on this, we draw the bar model here. Okay, so Mrs. Naidu 4 parts, the son 1 part. Mrs. Naidu, excuse me, 4 times as old as the son. So Mrs. Naidu 4 units, the son will be 1 unit lah. Okay, and then what did I say just now? I say when we are talking about the ages of two different people, remember this one, when we talk about the ages of two different people, always remember age gap is constant. So cannot be like, oh, the difference between my age and your age is 10 years, and then next year the difference between my age and your age will be 11 years. No. Because every year we are all getting older by 1 year. So let's say I am 40 years old. My son is 10 years old. The difference is 30 years, right? So let's say next year I now become 41. My son will become 11. The age gap remains as 30. The age gap remains as 30. So here will be 27. Because Mrs. Naidu 31 years old, the son 4 years old. So 31 minus 4 equals to 27. And this will be your 3 units. So 3 units 27. We are going to find 1 unit. 1 unit is 9. 4 units will be 9 times 4, 36. There we go. Answer is D. Answer is D. So those of you all who said she will be 36 years old when she is 4 times as old as her son, give yourself a pat on the back lah. The warm-up question, you did it. You did a great warm-up. Guys, help me to like and share this video, please. Yes, answer is D. Someone is asking me what is my favorite song. Well, I'm not a Swiftie lah, that's for sure. I hope you all don't cancel me for saying that. I don't know any of the Taylor Swift songs, but I like why am I even talking about this? Okay, never mind. We'll talk about this some other time. Okay, guys. So this was the warm-up question. Let's move on. We only have 1 hour. We've already taken up 9 minutes. Okay, question 1. Okay, before we go into question 1, before we go into all the questions, let's scroll all the way to the bottom. Let's talk about circle properties. Okay, quick recap guys, quick recap. I also need to recap because I don't teach circles every day. Okay, circle properties. What are some of the properties of a circle? So the properties of a circle is divided into the symmetry properties. Right here, the symmetry properties, SYMMETRY, and the angle properties. Okay, so remember, got 2 types of properties. Got symmetry, got angle. Okay, what are the symmetry properties? So all you all must memorize before you all step into the exam hall. Equal chords are equidistant from the center of the circle. Wow, what are chords? Okay, the chords of a circle are this thing here. I highlight for you all. I highlight in green. I like green. These are the this is a chord. This is also a. Sorry. This is not a chord. This is not the chord. This is the chord. This is the chord. Okay, this is the chord. So basically, a chord. Let me Google it for you so that I can tell you all what a chord is. What is a chord? Nowadays, you just everything you Google, the answer come out. Alamak, a chord in music is 3 or more single. Okay, that's not what I mean by a chord. Here we're not talking about a musical chord, guys. We're talking about a chord in circle, in maths. A chord of a circle is a straight line segment whose endpoints both lie on a circular arc. So example, okay, you have a line, you have a circle here. Okay, you have a circle. You have a line going from one side of the circle to another side. This is called a chord. Okay, this is called a chord. Alamak, why I use this one? Chord, C-H-O-R-D. C-H-O-R-D, not C-O-R-D. C-O-R-D different. That one, the chord, the wire lah. That one different chord one, not chord, and not the musical chord also. That one don't ask me. I'm not musically inclined. Okay, so chord in circles means a line where the endpoints of the line must touch the circumference of the circle. Now, it says here equal chords are equidistant. What is equidistant? Equidistant means distance the same. Equidistant means the distance is the same. The distance is the same. That is the meaning of equidistant. Equidistant means the distance is the same. Distance is the same from where? From the center of the circle. That's why you see here. Let's say I call this A, and let's say I call this B. So OA will be equals to OB. Provided. Alamak, why the thing so thick? Wait, hold on, let me change. Provided. This one I call it XY. This one I call it LM. Provided XY equals to LM. Okay, guys? Okay? Can see, very clear. So OA equals to OB, provided XY equals to LM. So if XY is 5 cm, LM will also have to be 5 cm. Then they are equal in distance from the center of the circle. Important, must wrap your mind around this. Don't just blindly memorize. Go and really internalize this. Must internalize all this. Okay, must make it a part of you before you step into the exam hall. Now, the perpendicular bisector, guys. You all know what a perpendicular bisector is. I hope I don't have to go through it again. The perpendicular bisector of a chord passes through the center of a circle. So a perpendicular bisector basically is a line that cuts another line into two equal parts. So you see here. Okay, this one I erase first. It's so thick. This notability is good but sometimes quite irritating because they, the pen is not so fine. You must change to the fine one. Okay, so the green one is the chord. Then this one is A. So you can see here because of these two lines here and these two lines here, we can say that XA equals to AY. Can you all see that? XA equals to AY. XA equals to AY. Okay, so because XA is equals to AY, we therefore say that AO or OA is the perpendicular bisector. And The thing about the perpendicular bisector is, true to the name, perpendicular, it forms a 90-degree angle over here. Guys, please like my video. Please like my video. Later MasterMaths don't pay me enough because they want to see how many likes I get. No, I'm just kidding. I'm just kidding. I get the same amount of money whether you like my video or not. Wow, thank you. Suddenly a lot of people like my video. Wow, you all are very kind people. Okay, thank you. So anyway, what was I saying? So the perpendicular bisector of a chord passes through the center of a circle. So you can see this is the perpendicular bisector of the chord. Okay, AO. AO is the perpendicular bisector of the chord, and it passes through O, the center of the circle. Passes through the center of the circle. So already we have talked about two things. Two properties related to the symmetry of a circle. Okay, what is the third point here? Tangents from an external point are equal in length. Okay, what is a tangent? Tangent is basically a line that touches a curve or a circle at one point only. One point only. It touches the circle at one and only one point. So tangents from an external point. This is the external point. So you all can see external point is the external point here. This is the tangent. Okay, I highlight. This is the tangent. This one and this one. Okay, so the tangents are equal. That's why they have this cute little mouse whisker over here or this cute little line over here. Looks a bit like a mouse, right? Or maybe I'm just imagining things. So the tangent here are equal in length guys. Equal in length. Equal in length. Okay, so tangents from an external point. So from from a single external point, they are equal in length. Someone is asking me, do you cover A-level maths? No, that one beyond my pay grade. I cannot do A-level. A-level is too difficult for me. Okay, O-level. Okay, O-level A maths can, but A-level, wow, that one, I'm sorry, can't help you. Okay, anyway, back to the question. Line joining an external point to the center of the circle bisects. Bisects here, okay. Bisects, sounds a bit wrong. Okay, bisects means cuts into two. Cuts into two equal parts. Okay, so line joining an external point to the center of the circle bisects the angle between the tangents. Meaning to say, this angle over here will be x. If this angle over here is x, this angle over here also x. Can see so it will cut the angle into two. Cut the angle into two. And this is very important. Why? Because then you can see that actually guys, can you see this? This is the beautiful thing about it. This actually becomes a right angle triangle. Assuming this line joins all the way Okay, but never mind, I don't confuse you all first. Okay, and then it can be a what do you call this? Congruent triangle. If you all have learned similarity and congruency, they can mix the topics together. Possible O-level don't think like, oh, if it's properties of circle, it's only properties of circle. No, they can combine it with other topics like congruency and similarity. Okay, let's move on to the angles This one is really the meat of the subject here Sorry to all the vegans out there, but this is what makes properties of circle. Usually when we teach this topic in secondary school, this is what we will start with okay? So we will start with the angle properties of circle. So this one all very important Tangent perpendicular to radius. Okay, you all know what a radius is Again, the tangent there, can see where is the tangent? This is the tangent AB. AB AB is the tangent. Okay, AB is the tangent. Okay. Alright. Tangent here perpendicular to radius. So when perpendicular to radius, that means this thing over here 90 degrees 90 degrees guys, can see perpendicular to the radius. Then guys, who can tell me what is this line called? I'm gonna highlight this line now. Okay, you all tell me what the line is called. Go and type in the comments. Okay, go and type in the comments, what is this line called? I'm gonna highlight it in purple. Okay, I like purple. Okay, what is this line called? Start with the letter D. It starts with the letter D. Anybody knows what is the name of this line on TikTok or Instagram? Diameter. Somebody say diameter. Very good. Okay, so this is called the diameter. So what does the diameter do, guys? The diameter cuts the circle into two equal parts. It cuts the circle into two equal parts. Okay, so when it cuts the circle into two equal parts, this is called a semicircle. Okay, I highlight for you all. This thing that I highlight here, this is called a semicircle. And what do you notice? Oh, there is a triangle. There is a triangle inside the semicircle. There is a triangle inside the semicircle. So let's say I draw another triangle here. The other side is also a semicircle. So there are two semicircles. There are two semicircles. You can see there are two semicircles. Okay, forming the entire circle. So this triangle, which is in this semicircle, this angle here, confirm plus chalk plus guarantee, as sure as the sun will rise tomorrow, this is a right angle, 90 degrees. If I draw another one, okay, I use a different color, because this one you all must understand the concept very, very well. This one also 90 degrees. Okay, if I draw another one, okay, I use brown. As long as you see the one side of the triangle has to be the diameter. The triangle has three sides, right? So one side of the triangle has to be the diameter. Has to be the diameter. This will also be 90 degrees. Okay? So this one usually very easy to remember. A lot of students will remember this one. Okay? So right angle in a semicircle. Okay, let's move on to the third angle property. The third angle property, equal angles in the same segment. Equal angles in the same segment. So this is an arc. You can see here. Okay, I use a highlighter. You can see there's the arc there. So from this arc, I extend to this angle, angle B. From the same arc, I extend to this angle, angle A. So I color here. This one is A, this one is B. So what can we say? A equals to B. Okay, equal angles in the same segment. This one very standard. Okay, a lot of students will remember this also. Okay, so you must remember. So let's say now I take out another one. Let me draw another one. So let's say now I draw like that. This one, let's say I call it C. Guys, will A, B and C be equal to each other? Yes or no? Will A, B and C be equal to each other? What do you all think? Yes or no? Can I get some responses, please? Okay, let's see. Okay, I want to see what people are saying on Instagram. Guys, A, B and C, are they equal? Okay. People are saying yes. Yes, good. Instagram got people say yes. TikTok, I don't see the people saying yes. Okay, yes, of course they are equal because very simple they are all in the same segment. Okay, awesome. Okay, finally, oh no, not finally. Number 4, angle at center is twice angle at circumference. See, I want to get your A1 not easy. Must really work hard. Okay, so angle at center is twice angle at circumference. What does this mean? It means that this angle over here, guys, is 2 times this angle here. There you see? That's why B equals to 2 times A. B equals to 2 times A. So let's say lah, example lah. Let's say now I say that this angle here is 70 degrees. Okay, if let's say this angle here is 70 degrees, my A is going to be 35 degrees. 70 divided by 2 lah. Example lah. So this one all quite standard lah. Angle at center twice angle at circumference. Okay, finally, this thing is what you call a cyclic quadrilateral. Remember, if you don't remember anything else from this live stream, at least must remember this. This is called a cyclic quadrilateral. Okay, let me spend some time now to explain to you all what a cyclic quadrilateral is. Cyclic quadrilateral. Quadrilateral means what, guys? Means 4-sided figure. 4-sided figure. It's a polygon that has 4 sides. Okay, so it can be a rectangle. It can be many things. I don't want to say that it can be a parallelogram and all that. Like you see, based on the situation. The important thing about a cyclic quadrilateral, the important thing is that the 4 vertices, these are called the vertices. You all see, okay. This one, okay, I highlight lah. This one, this one, this one, and this one. These are called vertices. So in a shape, the corners lah, you want to sound smart, you use the word vertices, singular vertex. The vertices are all touching the circumference of a circle. Okay, I write that down. Vertices are touching. Touching, that means not go across, not come out of the circle. They are touching only. The circumference of the circle. The vertices are touching the circumference of the circle. Then it becomes a cyclic quad. So remember this, cyclic quadrilateral. Usually sometimes your teacher will just say, oh, cyclic quad, cyclic quad. Cyclic quad means cyclic quadrilateral. So what is it about a cyclic quadrilateral? This is the thing about a cyclic quad. The opposite angles are supplementary. What does supplementary mean? That means they add up to 180 degrees. Okay? They add up to 180 degrees. So this chap over here, angle A and angle C add up to 180. This fella, angle B, angle D add up to 180. Like all other quadrilaterals, you take 1, 2, 3, 4, they add up to 360. Awesome, right? Okay. So those are all the properties that we have gone through. How long did we take? Wow, 8:30 already. Okay. These are the 3 golden steps before solving angle of circle problems. Okay, you mark out all the 90 degrees. You mark out all the radius. You mark out all the equal angles. Remember, mark out all the 90 degrees. Mark out all the radius. Mark out all the equal angles. And one more. Actually, there are 4 golden steps. Okay, the 4 golden steps are: you have to find the cyclic quad. When you have to mark out the cyclic quad. So I will write it here. So this one not 3 golden steps. We call it 4 golden steps. 4 golden steps. Number 4, mark out the cyclic quad. CQ here, cyclic quad. Okay. Steady? Okay. let's go into our question now. How many questions do we have today? We have 1, 2, 3, 4. Wow, 4 questions. Okay, 4 questions. Maybe one question we can take about 5 minutes. Okay, guys, in the diagram, AC is a diameter of the circle. Where is AC? Okay, so highlight so as we say we go and highlight. Okay, we go and highlight because they say to highlight the radius, right? This one is radius times 2. This is diameter. Okay, AC is a diameter of the circle. BDC equals to 40 degrees. BAD equals to 95 degrees. Okay, what else are we supposed to mark out? We're supposed to mark out the angles, right? Where are the angles? Sorry, mark out the equal angles. Where are the equal angles? I can see already. I don't know if you all can see this is one of the equal angles. Okay, so I color with my red color highlighter. This one and this one. Why? Who can tell me? Why is it CDB? Let's ask. Let's see if you all are paying attention. Why is CDB equals to CAB? Why? Who can tell me? Okay, let's check. TikTok, let's see. Anybody from TikTok can answer. Where is my live stream on TikTok? Why, guys? Why is CDB equals to CAB? Anybody on TikTok can answer? Hello? Rux of 241? What about you? Okay, maybe we can ask Instagram instead. Instagram. Oh, alternate no, it's not really because of alternate. Alternate, that means the lines have to be parallel. That means your BA and CD have to be parallel. But even then also, yeah, it's not alternate angles. But good try. Guys, why are the two angles there equal? Can anybody tell me not? Nobody Okay, because these are angles in the same segment. See? This one same segment, right? Alamak, using it wrong one. These are angles in the same segment. They both come from the arc BC. So BAC and CDB, they are both equal to 40 degrees. So the question is asking you to calculate ADB. And 95 here, mind you, 95 here is the whole thing. So this whole thing over here is 95. So if this is 40, this will become 55 degrees. Okay, CAD. Okay, so maybe you can write that down. So angle CDB equals to angle CAB equals to 40 degrees. Why? Angles in the same segment. Okay, then we can say that angle CAD equals to 95 degrees minus 40 degrees, which will give me 55 degrees. But the question here is asking for ADB, asking for this fella here. But what do we know? Actually, we know something already, right? We know that CAD is a right angle triangle. CAD is a right angle triangle. So if CAD is a right angle triangle, that means this fella here 90 degrees. Okay, remember, because this one is the diameter. Okay, I label here diameter. Okay, they say already, they say that AC is a diameter of the circle. Okay, so in fact, our working doesn't even have to include all these CAB and CAD. We can straight away just take 90 degrees minus 40 degrees to give me 50 degrees. Can you all see that? So 50 degrees for angle ADB. I highlight over there for you. Okay, so that is question number 1. Question number 1, done and dusted. Okay, 90 degrees minus 40 degrees. Very easy. Why? Because we know that AC is the diameter of the circle. So because AC is the diameter of the circle, I show you all again the property. Because AC is the diameter of the circle, therefore we use this one. Okay, I erase first. Okay, remember this angle will be 90 degrees because of the property right angle in a semicircle. So therefore, when we go to this question, we know that this thing over here must be 90 degrees. Let me erase. This whole thing over here will be 90 degrees. So if this is 40, this will be 50 degrees. 90 minus 40. Okay, let's move on to the next question. Let's see if we got any of y'all out there who can what, this one? That's radian all. Okay, never mind. Let's see. Okay, so it says here in the diagram A, B, C, and D are points on the circle with center O and radius 10 cm. A, B, C, D are points on the circle with center O and radius 10 cm. So obviously I know this one is 10 cm. This one is 10 cm. This one is 10 cm. Okay, and then I can see something. I can see that this one is angle at center twice angle at circumference. Can you all see or not? This is the angle at the center. It is 2 times the angle at the circumference. So this is angle at center. I highlight for you all. This one is angle at circumference. So what is angle BOD in terms of pi radian? Stating your reason clearly. Okay, come on. Let's see. How many of you all can answer this? Part A. Part A. I'm just asking for part A. Can you all do part A or not? Okay, I tick here part A. What's the answer, guys? What is angle BOD? Give the answer in terms of radian, in terms of pi radian. Anybody? Guys, if you just join us, please like my video. Please like my video, thank you. What is angle BOD? What is angle BOD? Who can tell me? Jing, jing, jing. Anybody? Nobody? Okay lah, you're waiting for the answer. Okay, so angle BOD twice angle at circumference, right? So we must take 2 times pi over 3. Because angle BAD is pi over 3. BAD is pi over 3. So must times 2. Juliana, you don't divide by 2, you times 2. Don't divide by 2, times 2, because angle at center twice angle at circumference. So this will give me 2 pi over 3 radian, RAD. Simple, right? So what is the reason? Reason is angle at center twice angle at circumference. There we go. What is the area of triangle BOD? Now they want to find the area. Wow, like very difficult like that. See BOD, where is BOD? There, this fella here. Okay, I'm gonna highlight for you all. Very fun do coloring on a Wednesday night. Thinking about all the bad decisions I've done in my life. No, I'm just kidding. Okay, that is triangle BOD. Triangle BOD. How to find the area, guys? How to find the area? You can use your formula, right? What formula have you all learned? Okay, if you are still stuck in primary school, the area of triangle will be half times base times height. But we are all in secondary school now, right? So what is the area of triangle in secondary school that we have learned? Who can tell me? Come on. Shout out your answer in the comments. What is area of triangle in secondary school? Balang Wakmat, who just joined. Can you give me the answer? What is the area of triangle in secondary school? Anybody on Instagram can tell me. Anybody on Instagram can tell me what is area of triangle in secondary school? The formula. What is it? Okay, let's see if those on TikTok have said anything. Don't see anything. Half AB, yes. 𝐒𝐞𝐫𝐢𝐞𝐬. Or is it 𝐒𝐞𝐫𝐢𝐿𝐴? Half AB sin C. Fantastic. Someone is paying attention. Thank you, thank you. So in primary school, we always are taught half base times height. But in secondary school, when you are asked to find area of triangle, you use half AB sin C. Half AB sin C, yeah? But in this case, when you want to use your sin C, guys, on your calculator, now I really need to go find my calculator. Because this one is a question involving sine. Cannot escape one. Where is my calculator? Okay, guys, you all try work it out. I'll be back in a jiffy. Maybe it's in one of my drawers here. Yes! I found it. Okay. Guys, very important. Very, very important. Must tell you all this. Can you all see this? Can you see no? Where's my calculator? Okay, never mind. I try to explain to you all. On your calculator, if you all have your calculator in your hand now, you see that there is a mode that you can choose. There is a mode that you can choose. So that mode needs to be set to radian mode. Cannot be set to degree mode. I say again, when we are trying to find the area of triangle BOD, I put the thing here. Danger! Do not leave your calculator in degree mode. Okay? Do not leave your calculator in degree mode. Switch to radian mode. Okay, smiley face. Okay, switch to radian mode. So now, okay, what is my half AB sin C? Okay, let's pull this out here. Okay. Okay, so area of triangle half AB sin C. Guys, by the way, if you all want to join our Telegram group, you get access to good PDFs, our formula list. We have a formula list or a book filled with formulas for those taking O levels. So please join the Telegram group. Join the Telegram group. I think I don't know how many thousand people are in the Telegram group now but just join, okay? We will give a lot of nice freebies every now and then. Okay, so area of triangle BOD, half AB sin C. So this will be half times 10 times 10 times sine 2 pi over 3. Okay, why 10 times 10? Because just now they tell you. They tell you that the radius is 10 cm. So you can see for this particular triangle, you can see this length here OB is 10 cm. OD is also 10 cm. Okay, so you need to have this length over here. You also need to have this length over here, and you need to have the angle in the middle, of course. That is your C. That is your angle C. Okay, so you key it all inside. Make sure that your calculator is in radian mode. You should get what do you get? I got 43.3. 43.3 cm square. Cm square lah, because the lengths are cm. The lengths are cm. Okay? So area of triangle, half AB sine C, half times 10 times 10 times sine 2 pi over 3. Remember, must change your mode to radian mode. Your calculator must be in radian mode for you to solve this question. Okay? Those on Instagram, Akil Adizan or Akila Adizan, I can't really tell how to pronounce your name. Did you manage to get it? 43.3 cm square. What about those on TikTok? TikTok, I've got how many people here? Okay. Anyway, that's question number 2. 2 questions down. Akil Adizan. Okay, thank you for correcting me. Yeah, you got it? Okay, great, great. Okay, 2 questions down, 2 questions to go. What time is it? Oh, it's 8:47. Okay, we got good time here. 13 minutes. Guys, please like and share my video, and please tell all your friends if you're in school and you've got friends and your friends are complaining to you, "Alamak, maths is so difficult lah." Tell your friends lah, join lah Wednesday live stream MasterMaths. No need to pay any money, just pay your internet bill. Okay, free. Good things must share. Okay, good things must share. Every week we are going through a different topic. So last week we did coordinate geometry. The week before that we did indices, and the week before that we did quadratic equations. Okay, so if you are sitting for your O-level maths this year, or you're in Sec 3 or Sec 2 and you're struggling with maths, you're like, "Alamak, I'm failing with my maths then come and join us for 1 hour every week. Hopefully from that 1 hour, it can be the start to doing better at your maths. Okay guys, question number 3. Let's see in the diagram, O is the center of the circle. Okay, so we can see over there, O is the center of the circle. RAQ is a tangent to the circle at A. So RAQ, tangent to the circle at A. Given that AOB equals to 76 degrees, so already if you know that this is 76 degrees, something should go off in your head. You should be like, "Oh, I think I know something." Okay. And AQB equals to 39 degrees. Calculate BAQ. Where is BAQ? BAQ, this one. BAQ. Okay, BAQ. So simple And then ADC. ADC. ADC maybe a bit tough. But can be done. Those who are experienced, you see the question, you can see certain things that most people cannot see. Okay? Okay guys, come on. Okay, what is the answer for BAQ? Who can tell me? BAQ should be quite easy lah. No, BAQ is... Alamak, what am I saying? BAQ is not the whole thing. BAQ is just this part here. I thought it was the whole thing. If it was the whole thing, it would be very easy. Okay, who can tell me what BAQ is? Go and try and work it out. Come. Try and work it out. I give you all 30 seconds while I grab a sip of water. Next week Ramadan already. But thankfully the live stream is at 8 PM, so I can still drink water lah. Okay, ZM Lion says the answer is 38. Anybody else has any other answers? Any other answers for BAQ? BAQ, any other answers? Okay, let's try. Let's try and see if we can solve BAQ lah. Okay, so when you look at the question, you should be able to tell me that, isn't this and this the radius of the circle? OA and OB, they are both the radius of the circle, right? So if they are the radius of the circle, this makes triangle OAB an isosceles triangle. So you know that angle AOB is 76 degrees. You should be able to give me this angle and this angle. How do I do that? Okay, so angle OAB equals to 180 degrees minus 76 degrees divided by 2 to find the base angles of an isosceles triangle. Now we're finding the base angles of an isosceles triangle. Okay, so grab my trusty calculator. 180 minus 76 divided by 2, 52 degrees. Okay, so your reasoning here is base angle of an isosceles triangle. Okay, base angle of an isosceles triangle. So after you calculate already, you can label here lah, 52 degrees. Now guys, this is your tangent. This is your tangent. This is your radius. So what should angle OAQ be? Who can tell me what will angle OAQ be? What is angle OAQ, guys? Anybody? Those on Instagram or those on TikTok, anybody can tell me OAQ, what's the angle? Anybody? What is the angle OAQ? Very good, thank you. I have one answer, 90 degrees. Akil also says 90 degrees. Alright guys, so 90 degrees, 90 degrees. So because it is 90 degrees, to find angle BAQ, we just simply have to take 90 degrees, subtract 52 degrees. So 90 minus 50 is 40, 90 minus 52 will be 38 degrees. So just now someone said 38 degrees, right? Just now we had an answer lah. We were asking what's the value for BAQ. Someone said 38 degrees. Who was it? Z_M_Lion. Congratulations, you got it correct. Okay, guys, what about ADC? What about ADC? Okay, don't tell me 90 degrees. Some students straight away they very confidently will say, oh teacher, ADC is 90 degrees. Why? Oh, because AC is the diameter. No, AC is not the diameter. You see, questions like this, you cannot just anyhow assume. This is the important thing that you all must tell your children, or if you are the children who is assuming such, you must stop assuming. When you do this kind of questions, guys, geometry, properties of circles, all this, the question must tell you explicitly that this is the diameter. If the question doesn't tell you, you cannot anyhow assume. But this one is quite obvious that it's not the diameter. Why? Because this is the center of the circle, right? So the diameter must go through the center of the circle. So AC is not the center of the circle. However, what is ABCD? What is ABCD? Those who know can comment inside the comment, please. What is ABCD? It's a special kind of quadrilateral. What kind of quadrilateral is that? ABCD. What is ABCD? ABCD is called a cyclic chord. Cyclic chord. Akil, we cannot call it a trapezium, because trapezium. Okay, guys, I don't mean to. Okay, it's not a trapezium because. Why is it not a trapezium? Because are we told that AD and BC are parallel? We are not told that AD and BC are parallel. So for a quadrilateral to be a trapezium, it must have one set of parallel sides. Must have one pair of parallel sides. This one doesn't have a pair of parallel sides, so it cannot be a trapezium. Cannot be a triple. It might be, but you cannot assume. That's why I say you cannot assume. Because here they never say. Nothing in the question tells you that, oh, AD and BC are parallel. Nothing. So we cannot say. But what do they say? They say that, well, they don't say, but they can show you quite clearly lah. You can see quite clearly that A, B, C, D, the vertices are on the circle. Okay? In fact, in all your questions, they have to tell you. Okay? So even though this question does not tell you, even though this question does not tell you by right lah, they must tell you that A, B, C, D, the vertices are lying on the circle. So very good, Lil Nuts Mummy. You said it's a cyclic chord. You are absolutely right. Okay, so now we know that it is a cyclic chord. Then what? Because we know it's a cyclic chord, therefore we can try to use this fact that it's a cyclic chord. How? Okay, let's think. Let's think. Okay. Maybe we need to find this angle over here. Okay, they tell you that this is 39 degrees. Okay, this is 39 degrees. This is 39 degrees. Fantastic. Okay, I can find out what this is. I can find out what this is. Why? Because AOBQ is a quadrilateral. AOBQ is a quadrilateral. It's not a cyclic chord. It's not a cyclic chord, but it is a quadrilateral. So I can find this angle here. And if I can find this angle here, let me think. The whole thing is 180 degrees, right? So I can find this angle also. Okay, why do I want to find this angle? I want to find this angle because if I can get this angle over here, then I know this is 180 degrees minus angle CBA or ABC. Okay, can see or not? So this angle here is basically 180 degrees minus this angle that I've colored in blue here. Okay, but how to find this angle? Okay, I know that this portion here is 52 degrees. But this portion I don't know, right? This portion inside there, the one inside here, I don't know. I don't know how much is that. Okay, but what I do know that OBQ can be found. So let me erase everything first. Okay, slowly. All this must do patiently Cannot. The answer cannot just come like that . And of course there might be another method of doing it . I'm not saying that my method is the only correct method . Don't get me wrong . Okay, let's find OBQ. Okay, so angle OBQ will be 360 degrees minus 90 degrees minus 39 degrees minus 76 degrees. Okay, can see so if you have this quadrilateral here, which is not a cyclic chord, but not a cyclic chord simply means that the four angles inside still add up to 360 degrees. So the special thing about a cyclic chord is just the fact that, okay, let's recap. The special thing of a cyclic chord is just the fact that your A and your C add up to 180, your B and your D add up to 180. If it is just a normal quadrilateral, you cannot say that A and C will add up to 180. Neither can you say B and D will add up to 180. But you can say that everything will add up to 360. You can still say that for a normal for a normal quadrilateral. Okay, so for a normal quadrilateral, we can still say that this is 360 minus 90 minus 39 minus 76. Okay, I'm running out of time. It's 9 o'clock already. So let me quickly try to finish this. Alamak, why is it red? Okay, hold on 360 minus 90 minus 39 minus 76. This gives me 155 degrees. Okay, so 155 degrees is this thing here. From here to here. Okay, from here to here. So this whole thing is 155 degrees, meaning to say this will be 180 minus 155 degrees, because the whole thing is on a straight line. Okay, so that's 25 degrees. Okay, so this fella here is 25 degrees. Okay, I shade it purple lah. Purple lah. So that one is 25 degrees.